Yesterday we talked about solving variables with both sides, or equations with variables on both sides. So today we're going to take and we're going to put all 5 of the steps we had on the board together. So I want to review again. I know we wrote these the other night, but we're going to write them over and over until we have them memorized. Remember, we always distribute first, if possible. And if you look, here is a review of the distributive property, where you take the number outside and you multiply it by everything inside. We are going to collect like terms. Remember, like terms are on the same side of the equals. We're going to move our variables to one side. Remember, we usually move the smaller, if possible. That isn't always possible, but if we can. We're going to do the inverse, or the opposite, undo the add, subtract, and the inverse, multiply, divide. So let's look at this example here. We have 3x minus 2 parentheses x plus 3 equals 5 minus 2x. We're not going to worry about those properties so much as we are explaining what's happening. So what do we need to do here? Remember, step 1 says distributive property, which we have right here. We have a distributive property. Now remember, the negative goes with the 2. So that negative 2 is going to get multiplied by the x and the negative 3, or the positive 3. This is the distributive property. And you can see when they did that, so this 3x just came down. Negative 2 times x is negative 2x. We have negative 2 times 3 is a negative 6. Make sure you're careful with your signs. And then they just brought this whole piece down because we haven't done anything with it. So the next step is to collect like terms. We have like terms right here. We have a 3x and we have a minus 2x. So we can put x's together. We can put regular numbers together. We can put y's together. So when we say 3x minus 2x, that's where they get this. Now remember, there is an invisible 1 here. And they're bringing everything else down. Let's collect like terms. So on this next step, if you look, they've taken, now normally we write it underneath. We're going to move the variables to one side. Preferably the smaller. We have 1x and we have a negative 2x, so when the negative 2 is smaller, the variable to one side. Preferably the smaller, which works out in this case. And so they've just written it in a line here. So when we do that, you'll see that these eliminate. We're going to combine these. Remember, there's a 1 here. 1x plus 2x is 3x. They've brought down the 6 and the 5. So now we're on to our inverse. So we're going to do the inverse. This is a negative 6. We're going to add it. So the inverse of subtraction is addition. You can see that eliminates. It brought down their 3. We're going to put these together. And now we're going to do the inverse. We're multiplying here, so we're going to divide. Inverse of division. And 3 divided by 3 is 1, because we want our variable alone and positive always when we are solving equations. Well, it is alone, it is positive. You can leave this 11 over 3. I prefer this way, actually, because when we get into slope, we're not going to see mixed numbers. If you wanted to write it 3 2/3, that's fine. Let's try another. I'm going to look at B here. 2 times 4y plus 3 equals 16. I'm going to zoom in here. We're going to talk our way through this. We're not going to worry about stating the property. So our first step always, it's going to come into focus in just a minute, sorry about that, is distribute. So we're going to have to say 2 times 4y is 8y. 2 times a positive 3 is a positive 6 equals 16. So now we can actually, we don't have like terms, we don't have variables on both sides. We skip to number 4, which is the inverse of addition and subtraction. So we're adding 6 to the equation, so we're going to subtract it. I'm actually going to write over here where I have more room. So 8y equals, well, 16 minus 6 is 10. So now we can do our inverse of multiplication, which is division. 8 divided by 8, we get that 1y, and again, you don't have to write that 1, it's invisible. Now, 10 over 8 is not simplified. If you're going to write this answer for me, you need to simplify it. It actually simplifies way too. So I will accept 5/4. This is actually the best answer. If you wrote 1 1/4 or you wrote 1.25, I would accept those as well. Let's look at D. Now D is very ugly. And if you're what we call a fraction fraidy cat, this is going to be very intimidating for you. But I'm going to show you a way to get rid of fractions, so that then we're only dealing with whole numbers like this. So in order to get rid of a fraction, I've got some space over in my margin, so I'm going to write this one in the margin so you have more work space. And we're going to come over here. You can see where I'm at. I'm just going to rewrite it 3/4 A, or if you wanted to do it in your journal, if you have more space there, that's fine. 2/3 A plus 1/4. Now, in order to get rid of the fractions, kind of like the decimal one we looked at the other day, they multiplied by 100 to get rid of the decimal. We need to figure out what is the common denominator. Well, we have 4, and we have 6, and we have 3. So the common denominator here is going to be 12. So we're going to multiply, we're going to distribute, like it says up here, 12 or 12 over 1 on each of these terms of the equation. Okay? I'm going to write it out so you can see all of this stuff, but if you get to a point where you're like, I don't need to write all the steps, I can do 12 times 3/4 in my head, that's fine. But I want you to see the different pieces. So if I have 12 over 1 times 3 over 4, we learned last year, we can, and actually in 6th grade, we can cross reduce. 4 goes into 12 3 times, so 3 times 3 is 9. So this becomes 9, don't forget your A. I'm going to do 12 over 1 times negative 1 over 6 again. I can cross reduce. So this becomes 2 times a negative 1 is a minus 2 equals 12 over 1 times 2/3. I'm going to cross reduce. This becomes a 4. 4 times 2 is 8. Don't forget the A. And then I have 12 over 1 times 1/4. And again, cross reduce. 3 times 1 is 3. And now that looks a lot nicer than all of this ugly fraction. So we've distributed on step 1. Step 2 said collect like terms. We don't have any like terms because they're not on the same side of the equals. Step 3 says move the variables to one side. Well, which is smaller? I have a 9a and I have an AA, so this one is smaller. It's a positive, so to move it across the equals, remember we have to do the opposite. So I'm going to minus 8a from both sides to keep my equality. 9a minus 8a. You can write the 1 if you want, or just a. Bring down your 2. Bring down your 3. Now I'm just doing my inverse of subtraction. So I'm going to add 2 to both sides. A equals 5. And I'm finished. And we can always go back and check it. We can check it by plugging it back into the original. But A is 5. That means 5 is the solution because it makes both sides of the equation true. So let's look at this in a word problem format. I'll zoom out a little bit so we can see the whole thing. Bags of maple granola cost $2 more than bags of apple granola. Owner ordered 6 bags of maple and 5 bags of apple. The total cost was $56. So what we need to do is before I even look at this, I'm going to make a couple of notes to myself. So if maple is 2 more than apple, well, maple is, or cost, which is your version of equals, 2 more than apple, because I just want to see what's happening. 6 bags of maple, so 6 maple, and 5 bags of apple, total cost is $56. So here are my 2 separate equations, and then we're going to do some different things with this. M is the cost of maple. Okay, we use M. Write an expression. Remember, this is no equal sign. For the cost of 6 bags of maple. Well, we did that. We did that right here. 6 maples, 6 M. Use the variable M to write, again, an expression, no equals, for the cost of a bag of apple. Okay. Up here, we wrote the cost of a bag of maple. If maple is 2 plus apple, but now I want to know, how do I figure out how much apple is? I can rewrite this and say apple is, if it's 2 more apples to get maple, then if I take my maple minus 2, I'm going to get my apple. So maple minus 2. If you wanted to change this to an equation, then you could say equals A. That's up to you. Write an expression for the cost of 5 bags of apple. Okay, based on what we've written here, if this is the cost of a bag of apple, right here, and we want 5 of those, then I'm going to say here is 1 bag of apple, and I have 5 of them. And that's going to be where we see distributive property in real life. Now we're going to write an equation, so this is going to have an equal sign, to show the cost of 6 bags of maple and 5 bags of apple for 56. So we cannot write this equation with the 2 different variables. We're wanting this to have 1 variable, which if you look, 5 apples we wrote right here. So we can write 6 bags of maple plus, instead of saying 5A, I'm going to say 5 times the quantity of M minus 2, because this is my 5A, equals 56. So what I would like you to do is I want you to do E. And that is what I want you to answer on at the end of the video and submit. Make sure you click done. And then tomorrow when you come to class, we're going to do some more practice with using all of these steps in the same equation. Have a good night.